Today we are going to discuss block diagram. First one, we list several symbols. For discrete system, LTI system, basically we have three fundamental operations. The first one is the addition of two sequences. The second one is one sequence multiplied by a constant. For example, multiplied by 10, multiplied by 3, or something like that. The next one is ideal delay. So we have a sequence xn, then we delay by one time, x give us xn minus 1. So the symbols for these three fundamental operations are as this. The first one is addition. Addition of two sequences. So we have x1n and x2n. So x1n plus x2n. And we are going to use this a circle, a plus. So this is x1n. And this is x2n, and we have an arrow in here and another arrow in here. So we have two input sequence, and the output, this arrow is out. So that means this is out, and this is xn1n plus x2n. Okay? So we use this symbol to represent the addition operation. The second one is multiplication by a constant. By a constant, for example, a. We have an input sequence, so xn, because we have only one sequence, so it's xn. Then multiply by a, we get axn. So what we have here is we only have an arrow. That means this is the input, right hand side is the output, and we put here a constant a. The next one is unit delay. Delay by delta n minus 1. And this in Z transform, we know this is in time domain, right? In time domain, the unit delay corresponds to Z transform. Z domain is Z to the negative 1, to the power of negative 1. We know the Z transform of this means corresponds to this. So if we have xn, and we want to delay by one time, and we have this square here, and we write z to the negative 1 inside. That means delay by one time. So what we have on the right hand side, and this will be xn minus 1. Any questions so far? So we have these symbols for the three fundamental operations in a discrete system. The addition of two sequences and multiplication of one sequence by a constant a, and the unit delay of a sequence by one time, unit delay. So this axn equals xn times a, and this y output equals x1n plus x2n. All these arrows must be here and must be in this direction. Means this one is the input, this is output. This is input, output, input, input, and output. Okay, next we use an example to show how to use these symbols to represent a linear LTI system. Block diagram representation of a difference equation. And the difference equation is very simple. Yn equals a1 times n minus 1 and plus a2 y n minus 2 and plus b sub 0 times input xn. What order is this system? First order? Second order? What is it? Second order. Okay? We only care about the y. Okay? We don't care about the x, the input. The order of the system is determined only by the output. So the highest is n, the lowest is n minus 2. So the difference between these two is 2. So that's the second order system. Okay? Corresponding, for example, if this is a differential equation, then one example is a second order circuit. And we know that means we have a capacitor and the inductor. Okay, so here, how to use a block diagram to represent the implementation of this second order difference equation. First one, we have enough space here. Right? We have this one is the output, so must be on the right hand side. And the input is xn, so we write this one on the left hand side. So xn here. Then we know that we need to multiply by b0, right, by a constant. So that means this one go this way and b0 like this. Then we need to add this term here. So add, so that means the addition of two sequences. So we have an addition here. So this one is this. Add, for example, we do this first. This one is, for example, okay, so we write the output on the right hand side. And this term is the delay of the output. The output is here on the right hand side. So we know Yn is here, and we need Yn minus 1, which is unit delay. So we are going to go this way, and right here, z to the negative 1. So what we have here is Yn minus 1. So this delayed by time. Does that make sense? Now, for this one, we need to multiply by a1. So we go this way and add to this, but we have a1 here. So that means Yn equals the addition of input times b0, then plus the delay, unit delay of output, which is Yn minus 1, then times a1. Okay, add to this term. Sure, we still have another term to treat, but right now this Yn equals this plus this. Does that make sense? Right. Now we need to consider this term. This term is Yn minus 2. We know we have only I unit delay here, and we know this is one time delay from Yn minus 1. Okay, so we go from here. This is Yn minus 1. Then we delay one time again, so z to the negative 1. And we know from here, this gives us Yn minus 2. Because it's delayed, unit delay from unit delay of Yn. Then we go here, and we need to add this to here again. So this one go up, and this one is a2. This is the block diagram implementation of this different equation. If we are given this, we should be able to draw this. If we are given this block diagram, we should be able to write out the difference equation. So from here, we go here. So Yn equals, and this time this, plus Yn minus 1, then times a1, then plus yn minus 1, which means yn minus 2, then times a2, okay, add up together, get this. We should be able to, these two are equivalent, so we should be able to do from here to here or from here to here. So every time you see this block diagram, you know the difference equation is like this. Any questions? So this is a very simple example, second order difference equation, second order system, and we used all the three fundamental operators, addition, multiplication with a constant, and unit delete. Okay, next. We discussed the block diagram implementation in general. So general form of difference equations. The general form is we mentioned this before. On the on the left hand side, it is the linear combination of the output. So that will be k from 0 to n. That means this is the nth order system. And ak y n minus k, and k from 0 to n, capital N. So that means this one equals a0 yn minus 0, which is yn, plus, when k equals 1, it means a1 plus times yn minus 1. Then plus a2 yn minus 2 plus a3 yn minus 3, and all the way to a capital N yn minus capital N. So this is the nth order system. This is all the combinations, linear combination is this constant, linear combinations of the output. On the right hand side, similarly will be the linear combination of the input. So that will be k from 0 to capital M. This M can be equal to N, can be not necessary. And bk and x n minus k. So this is the general form of difference equation. And as we said, this term here, the a0 yn plus a1 yn minus 1 plus something equals something here. We would like to make a0 to be 1. So scale this one to 1. If you are given a system a0 is not equal to 1, then you just divide it by a0 on both sides. So make this one equals 1. So we always make this one equal to 0. Equals 1. That means we always have this term yn only. Then we write here a0 equals 1. All others are just no matter what we have. Does it make sense? So in the general form here, we make a0 equal to 1, and all others as just constants. If in real life this one is not equal to 1, you just divide it by that number, so you scale this to 1. So this is a alternative form. So a0, which equals 1, so we have yn minus, we are going to use minus. All these terms we switch the sign. So k from 1 to capital N, ak and yn minus k equals, the right hand side is the same. So that is k from 0 to capital M and bk and x n minus k. Right? So this ak here is a negative ak here. Does that make sense? So we need to memorize this one. Right? So the a0 is always equal to 1. The other term will be, we use negative sign. For example, yn minus yn minus 1 plus 2 yn minus 2 equals xn, like this. Okay, this is already good enough, right? So the coefficient equals 1. What is a1? 1 or negative 1?
Negative.
1, right? Okay, so this one is negative here. So make sure a1 here is 1. What is a2? Negative 2. Again, there's negative. So this is positive, so a2 is negative 2. Don't make a mistake. Right? And what we have here? We have b. Which b we have? b0, right? b0 equals 1. And all others, b1, b2, b3 is all are equal to 0. Right? So given this, we know all these b's, right? And coefficient a case and b case. Alright, we write this one as make this simple, easy to understand. We write this one as V capital N. Vn. So you can see Vn equals the sum for this one. So this is addition. So this is looks like an output of all this, the summation for all this linear combination of the input. So this term equals, we write this term equals Vn, and we just write this one equals Vn. That means Yn will be equal to Vn, this term, plus all other terms move to the right. So that will k equals 1 to capital N a k y n minus k. Those are just the alternative notations, so no big deal, no any. Right? Just memorize this one. We need to use the negative, and we can write this term as the sum of sum. So this is only one term, the summation of all the input. Okay, so now we are going to implement this. How to implement this? With the block diagram. Okay, before we discuss that, we want to write the system function. You still remember the system function we discussed last lecture? If you are given a difference equation, how to calculate the system function? Or the z transform of the impulse response. You are given the difference equation, this, or doesn't matter, right? You take the z transform on both sides, and you convert the time domain difference equation into a equation in terms of z, and xz and yz. Then the system function is defined by yz over xz. Is correct? Right. So now you should be able to easily write out the system function from here. Right. Let me give you a hint first. For example, here we take the z transform on both sides. So this one will be yz, right? Capital Y, right? Yz, and minus the sum of all these terms and ak, and this is the linear property of z transform. So ak times this one. Yn minus k, we consider the initial conditions are all initial conditions are equal to 0. Right? So this one will be z to the negative k. That's a delay by k time, right? And this one will be yz. Okay, this is done for the left hand side. Okay, right hand side will be equal to k from 0 to capital M and bk. What do we have here? Z to the negative k. And xz, right? So this is yz, this is yz here. Okay, I can move this yz outside, and there's 1 here, and like this. So this one will be gone. Combine this. So the system function, by definition, is yz over xz. So which is yz or xz. So this term will be on the bottom. This term will be on the top. Okay? So this one will be sum k equals 0 to m bk z to the negative k, and 1 minus k equals 1 to capital M, and ak z to the negative k. Does that make sense? Last time we said, give you difference equation, you should be able to write out directly the system function. You just imagine the z transform in your head, then you can write this. If I give you the system function, this, you know this is equivalent to a difference equation. So you can directly write out from here the difference equation. Yn minus all these sigmas ak yn minus k equals the sigma bk, the sum bk x n minus k. So on the bottom, that are the coefficient for the output for the y, okay? Cross product, and on the top, those are the coefficient related to the input. So you should be used to this. Right? Any questions so far? Right? So these are the system function. Right? So I give you this difference equation, or I give you this system function. Either way, they are equivalent. I let you to implement with the block diagram. That is our purpose, objective for this. Right? I'll give you this here, or I'll give you this. They are the same. Then we implement with the block diagram. Okay, we start from here. We know, see this Yn equals here, equals this term plus this. We know this term equals all this. So now you can imagine, right, the block diagram. Those are the delays of the input. Those are the sums of the input. So we are going to put the input on the left-hand side, the output on the right-hand side, then there are some delays, then coefficient multiply, then add all this together. So you can imagine the block diagram, right? So now we have this. So this is xn input. The first one is multiplied by b0, right? The first term. This one here, b0. Then we are going to add some term. And we need to have a unit delay of input. So this here we are delayed by one time. So we know this one is xn minus 1. And then we need to multiply by what? B1, right? Multiply by B1. So we can write here. So okay, we put this beautiful. Right? So this one is times B1. Okay, so here we are going to have addition. Then we to this. Right? So this here, you think this one will be some Yn. Right? We just haven't finished yet. So you can see Yn equals B0 times xn, then plus B1 times xn minus 1. Right? That looks like we are in the right way. We haven't finished yet. So now we have next one. So delete by another time. Then this one gives us xn minus 2. So this part here, we have this. This one will be b2, and we have a lot of terms all the way up to -1, and this gives us xn minus capital M, and this one here, we don't need this, right? So there's no addition. This is the last term. So we all the way, so we have up, and this one will be B capital M. Any questions on that? All this add up together is we call this Vn. So okay, Vn is here. So this is Vn. So Vn equals this times B0 plus xn minus 1 times B1 plus xn minus 2 times B2 and all the way. That is Bn. That is Vn. This one here. So Yn equals this. Then we need to add all this. So if we write directly here, that means Yn equals Vn. Why? Because there's 1 here. We don't need to write that 1. So Yn equals Vn times 1. So that means that. Alright, we need to consider the second term, which is here. So delayed by 1 time, then times what is the coefficient to here? A1 or negative A1? I'm trying to trick you, okay? So A1 or negative A1? Negative A1. Negative A1, okay, now look at this. Yn equals this term, we already implemented on the left hand side. N. So that's why we write this negative, because when we move this one to the right hand side, it will be plus. So it is A1, not negative A1, right? So this here will be multiplied by A1, then go up. So here is plus. Make sense? Then similarly, this is another delay, and this one will be A2, and here, so this one. If we stop here, then we don't need the plus addition here. But it looks like we have more terms, so we need to have this. All this one, the last one, the last one will be another delay here, and this one is An, and here. I align this one, looks like okay, the number of branches here equals the number of branches here. Not necessary, right? Because n, this capital M and capital N are not necessarily equal. If M is large, then this one larger than that, then this one will be longer than this one. If this one is larger, then this one will be deeper, right, than this one. But anyway, it must be like in this form. Does it make sense? And we call this, it's called direct form 1. Right? This is called direct form 1. Right? The block diagram implementation of a direct form 1. So if I give you a difference equation, can you draw the block diagram in direct form 1? Here you need to make sure the y0, the coefficient to yn must be equal to 1, and those b's are the coefficient for input. Those coefficient a, k's are the negative coefficient of the output. And you need to have these arrows in this way, right? You cannot skip these arrows, and you cannot make in the wrong direction. And because this means this is the input, this is the output, this is the input, this is the output, right? Any questions? Okay, look at this system. So okay, so let me write here. So this one is this is Yn here, and this one is just like this. This system is the implementation of the general form of differential equation. But we can consider this is a cascade of two systems. Just two systems are in parallel, in series. Right? So this is the first one, this is the second one. And we just, in series, we connect these two systems in series. Does it make sense? If two systems are in series, we can switch the position of this, right? So that means I can write this first, then move this one to the right hand side. Does not change anything. Alright, so let's do this. This Vn is not necessary, right? So we don't need this anymore because this one here is just the digit. Okay, so if I do and this is I will move this one to the left hand side. So we have, keep in mind this xn is here, and this is the connection. So if you think this is a black box, so it's like this here, and this is the output, this is the input. I change the position of these two systems inside the box, but I don't need to change this x and y. This is still input, this is still output, right? Alright, so what I have is here, this is a plus, and here, that is, go this way, and delete z to -1, z to negative, and minus -1 here, and all z to -1, and this here, so that is a1, plus, that is a2 up, and this one here, this is an, and this one here up, and this one here is xn. Is this correct? This one is this part. I just move this part to here. So this plus is this plus, this plus is this, right? And this one deletes here. So this is equals 1, right? Because this one equals 1 here. Okay, so a1, a2, and all an, or this one. Okay, and now I move this part to the right hand side. So again, straight line here. So I will have this one delete z to -1, and this delete z to -1, and all this z to -1 here. And this will be, there's a b0, and this one will be, what is here? What is the signal here? Yn, right? The input output. So Yn, but this one times b0. Right? And this one here, what is here? B0 is here. This way is B1, right? Alright, so B1. Which direction?
Left.
To the right, right? Okay, to the right. And this one here, B2 to the right, and here, this is B, last one, BM, then, okay, okay. Questions on that? This is equivalent to this. Yes or no? But all the arrows, all the coefficients must be like this. So A1 is in this direction, it is in this direction. A2 is in this direction here, and delete like this. It's good? So you believe these two are equivalent, right? Okay, now look at this. This one is just a straight line. So theoretically, you don't need to draw a line. So you just like 1 point, right? And so we still draw this line here, but you know, this is connected to here. So if I do like that, any questions? No problem at all, right? Because this is straight line. So I can connect like this. Okay, so now you can see, right? I'm making this beautiful, so I still write here. So what's the point? We have two sets of these deletes. This one here is equal to this. So delete by 1 time here, delete by 1 time here. Are these two are still the same? Still the same, right? So that means we don't need this. We can just connect this line here, okay, directly from here. Because they must be the same, right? So I don't want to mess up this. So you can see we are going to combine these two, so eliminate another sign, another. So what we have here is okay, let's see. Okay, let's remove this. Erase. Okay, next one we are going to combine this delete unit as xn here, and this plus, and this here plus, plus, and this one, the last one we don't need the plus here, and delete here, and there's a not a delay. Right, so this go this way. Okay, no. Go this way here. This not go this way here. So this is A1. Usually we write this area in the middle. A2, and all this one here. This is A. This is the left-hand side. The right-hand side, we said we remove this. So this directly from here, and keep in mind we have a B0 here. Right? And this one will be an addition, and this one will be a YN. And this one here goes up, and this one here will be a B1, and this one, right? So there's another one, so B2, and this one here, BM, right? And like this. Is good? Right? So this is called direct form 2. Right? This is called direct form 2. I write like this one's here, and this one's direct form 1. Actually, we can. Okay, we can erase this, right? I want to put these two forms, one more. Right? So here, this one is gone. Let me draw this. Direct form 2. Let me read. This is good? This is direct form 1, this is direct form 2. Block diagram implementation. Okay, next we discuss examples, but I will put this the forms here and let you do the examples. I'll just put this one at this side so you can see. No one looking at the slide. Everybody get a piece of paper and do the practice. Direct form 1 implementation of an LTI system. The system function is hz equals I put this here is for your convenience. So I don't need to do like that, but you should be able to know hz equals yz. This one. So I give you this. So 1 plus 2z to the negative 1, 1 minus 1.5z to the negative 1 plus 0.9z to the negative 2. I'll let you to implement this with direct form 1, this transfer function. As I said, I don't need to give you this. I only hz equals this. And you can look at the cheat sheet on the right hand side. direct form 1, the template is on the right hand side on the top. You need to write plot in that form. Okay, nice. You can try this. Don't look at the slide. Okay, you can try the direct form too. Try to understand what we have here, right? Then figure out what to do this. Okay, look at this first. If you are given the direct form 1, what is the difference equation? Look at this here. What is the difference equation? Yn equals what? Equals b0 times xn, right? Plus b1 times xn minus 1, and plus b2 xn minus 2, and all the way to bm times xn minus m. Then plus a1 yn minus 1 plus a2 yn minus 2, and so on. What is the transfer function for this? What's the transfer function for this one? You already know the difference equation here. So the hz will be equal to yz over xz. So with y over x. Now we consider what's on the bottom. The bottom is yn, so it's 1 minus ak sum of ak and z to the negative k. And on the top that will be the sum of bk and z to the negative k. So from this diagram we know this. Now from here you need to be able to draw that. So now we are given this. So look at this transfer system function compared to this. You know what are the coefficient A Ks, what are the coefficient B Ks. You can discuss, right?
Yeah.
Yn equals xn times 2 xn times 1 and 2 xn minus 1 plus, okay, and plus 1 okay, look at this. Yn equals this part is good. So Yn equals xn plus 2 xn minus 1. So that is good. Xn plus n, right? then plus 1.5 yn minus 1, right? But you said, what you said here is minus 1.5. So think about the sign of this. You need to understand the meaning of this, this system function, and also derive the difference equation. Then it is very clear how to draw the diagram. Yeah. Look at here. This minus ek, but what we have here are all positive ek. So you need to understand why this is negative ek here are positive ek. That's what I said. So this is yn equals something. This one is negative is on the left hand side. So you need to move to the right hand side. So this will be plus 1.5 yn minus 1. You need to convince yourself. So, yes, I'm correct. Okay, so yn equals, what is b0? What is b0? 1. Okay, so you can write b0 just 1. Just 1. That means yn. This one you don't need to. Yeah, 1 you can write 1. You don't need to. 1 you can just line that means 1. Because the straight line means all paths filter. That automatically means 1. If you have a straight line, it means x equals y, y equals x. So it equals, because yn equals, all this add up together equals xn times 1, right? Plus 2 times xn minus 1. Right? That is correct for the input part. For the feedback, then yn equals all this plus 1.5 yn minus 1. But in the formula is minus 1.5, but it will be on the left hand side. Right?
Oh, so there's a...
No. So in the system function on the bottom, that is 1 minus 1.5. So you consider all those cross product, that is yn minus 1.5 yn minus 1. But you need to move all the terms other than the yn to the right hand side. So this one will be plus. So negative 1.5 on the bottom, you need to have positive 1.5 on the right. So you understand this y is 1.5. Okay, so this good. Then this one, on that one is positive, so you need to be a negative 0.9, right? Make sense?
Yeah.
Okay. And this direct form 2, you just need to, you need to go this way first, so that will be second. Right? Yeah, so this is yn equals, this is 1 again, right? Then plus, and keep in mind, direct 2, all the arrows goes both sides, left and right. This one goes to the center, this one goes to the side. So this one be 1 times xn plus 2 xn minus 1. Then this one is supposed to be positive, so plus this one, right? This one minus so here, what you need to be able to do is, I'll give you this function, you can directly write this. So just 1 here, 2 is here, right? And this is 1 is here, negative. Negative this coefficient here, negative this coefficient here. Make sense?
Yeah.
Okay? Yes.
I have both of them, but can you explain why you have 530
Okay, let's see this. From this system function, if you write the d, so this is give you yn, right?
Yeah.
Minus 1.5. This is yn minus 1, right? This one, right? And plus 0.9 yn minus 2. So that is the inverse of the
So
transform.
now you should take it to the, I forgot to, okay. Yeah.
Right?
Yeah.
Then equals this means xn plus 2 xn minus 1, right? But when we implement this, we move all the terms other than this to the right hand side.
So you have negative
So this one you need to move these two terms to the right hand side, so that will be 1 plus 1.5 yn minus 1 and minus 0.9 yn minus 2.
Okay.
So now you implement this thing. So yn equals this is related to this input term. This one is feedback delay by 1 time, then times need to be plus 1.5. So this is plus. Similarly, this must be minus.
Okay. Also, when n and k are n and m aren't equal to each other, do you have to do something like this?
Oh, okay. So in this one, here there's only one. You don't
For
need,
direct.
yeah, you don't need this.
Okay.
No, let me see. This one. Okay.
For direct form.
So direct form 2, you need to move this one to the left, but all these coefficients are. So this coefficient are wrong. This one needs to be so plus, right? So let's make this correct.
Yeah.
So this one. So this one needs to be plus 1.5.
Yeah.
You need to move all this to the left. So this one needs to be negative 0.9. And this one is gone because this one has no. You need only this one.
Okay.
So it's like this.
Okay.
But the coefficient, and this one to the left, so this one must to the left. This one to the right. So all this to the center, but this one will be to the side. This one to this. So you just try to think about this one, understand what we are doing in physics, then that's no big deal. It's very simple to understand.
Okay.
So everybody got it? Let me see if you have. Okay. You don't need this addition, right? Because there's no addition. But the last one is just directly connect to this one. And also this one, you don't need it. So this one is good, this one is good, this one is good, this one is good. Yes. You don't need addition here, right? You don't need this circle with plus here, because this one is directly connected to that. Everybody got it correct? Direct form 1 and form 2? Okay, form, which one is, this is form 1, right? Okay, this 1, good, this 2, and plus, yes, minus, good. Okay, you don't need to write all this. You write that that is not wrong, but you don't need to write this. What the most important is, when you do the homework or the test, you need to write clear the direction of the arrows, and mark clearly the coefficient, and the element, addition, all those things. All others like yn minus 1 yn, you can write there for your, easy to see clearly. Or you don't need to, but all others, the arrows, the elements, the block, the symbols, and the coefficient must be there. Right? If there's only thing exception is if the coefficient equals 1, you don't need to write 1, and you just write the arrow. That's it. Or you can write n, but you don't need. All others must be there. Okay. Okay, you can finish it. Then you do the form 2. If you finish form 1, then you try form 2. Right? Form 2, usually at the beginning, You write the form 1, then you switch, you combine, you get the form 2. But a later time when you are used to it, you can directly draw the form 2. Right now, no matter what way you use, you can write, you already have a form 1. Then you can just switch the position, combine the elements, then you get form 2. But keep in mind the correct direction of the arrows. In form 1, all the arrows are directed to the center, to the middle. And in the form 2, you need to keep the direction of the arrows. So it means they are directed to the side, to both sides. And also, the A1s and the A case and the B case will switch. So in form 1 here, this A on the right, B on the left. In form 2, A will be on the left, and B will be on the right. And all the arrows must be in the same direction. So you can see here, all the arrows to the side, these are all the arrows to the... in this example, this is the second order, right? And the input has only deleted by 1 time. So that means this is unbalanced. So you need to be able to determine which one you don't need the addition. If you already finished form 1 and form 2, now consider what is the cost for this implementation. That means how many elements, how many additions, how many multiplications, most important, how many delays do you need? And because when you implement this system in real life, you need to, if you have a delay, you need to have an element delay. So how many? Any questions? Everybody finished? How about? It's good? Okay. Those B's, you cannot just be B0, B1. You need to tell me what B0, what B1 is. Okay. So in this example, B0 equals 1, right? Yeah. So this means you put a 1 here, or you don't need to put this one. And B1 is, what is B1? B1, all the B's are on the top, right? All the B's are on the top. So for this example, so this is B0, this is B1. So B1 equals 2. You cannot write just B0, B1. You need to tell me this. So this is B1. And this one is, A1 is a positive 1.5, right? Yeah. Right. And this is B2. B2 equals negative 0.9. Right? If you already finished, I'll give you another. You try. For example, if I change this one to plus 0.9, z to the negative 3, keep all others the same, but only this part. Negative 2 change to negative 3. Can you imagine how to do this? You need an extra unit delay, right? But on the top, you don't need to write the addition because we don't have we don't have A2. A2 equals 0 here. This one equals A3, right? So you have only 2 unit delays connected. You don't need to have this error. Right? Does that make sense, everybody? Okay, any questions before we stop? Okay, that's it. Thank you. As we said, now it's time for you to read the lecture notes. You need to understand what we are doing here. For every example, you should be able to convince yourself, yes, that is correct. If you find any errors, let me know. I cannot guarantee no errors. Okay, thanks, bye.